Now how many ads we're going to purchase, so that's our changing cell. So these are the 4 changing cells, one for each medium, and we will color code that with that. Okay. So now we have the budget constraint, and then okay, the number of ads constraint. Okay, so the limits are, so the limits come from here, right? So okay, the limits are here in a row. So this is TV, daily newspaper, this is 30-second radio, this is 60-second radio. So here we have set it up as rows, and the limits must come here, but the limits are given in a row in the input table. So how do we get this here without copy pasting or just typing those numbers again? Okay, remember, the input values must all be entered just once, and then they must be referred back with formulas. So when you want to change orientation from a row to a column, we can use transpose function, and transpose function is an array function. So you have to enter an array function not in one specific cell, but from in the entire range. So here there are 4 cells that are arranged in a row, and we want those 4 cells to come in here in a column. So highlight the 4 cells and then use transpose. Alright, so now close parenthesis, and since this is an array function, you shouldn't press the enter key. If you press the enter key, it won't work. What you need to do is to, with your left hand, press the control and shift key. Keep the 2 keys depressed. Control and shift key must be depressed, and then press enter. Then the array function will be entered, and you can see the squiggly marks which we did not type. The Excel automatically inserts those squiggly marks to indicate that this is an array function. Array function cannot be altered. The individual cells in an array function cannot be altered by itself. So if there is a mistake or something, you want to change it, then you have to go and redo the entire range, and then you can edit, and again you end the editing with control shift enter. Alright, so now no more than 12 ads. Okay, so that again, okay, these 4 cells are coming from here, right? So again we can enter a transpose function for that. Okay, highlight the 4 cells and then type in the transpose function and then control shift enter. Okay, so these are less than or equal to constraints. Again, you must indicate what type of relationship there is between these two, whether less than or equal to or greater than or equal to, by entering the labels. And then lastly, radio ads. Okay, the radio ads, there are 2 of them, that plus that. Okay. Now those 2 ads must be at least, so now this is greater than or equal to. Alright, don't type in the number 5. Okay, we've already entered the number 5 here, so you must refer back to that cell. Okay, you should never enter the same input value twice in a spreadsheet. Okay, so we have now set up 5 constraints. Now we have the budget constraint. Total cost must not exceed 8,000. So this limit is that, and then the total cost for radio will be that. So here the total cost is some product of cost per ad comma, how many ads we're going to purchase. Okay. Close parenthesis and enter. Okay. The next one is the radio cost must not exceed 800. So here this is about just these two. So we can again do a sum product. Now this time you do the sum product for just the radio portion. And these should be less than or equal to, so like that. So now we have to set up the objective function. Objective function is the audience that we reach. So the audience we reach will be the audience reached per ad is given in this row, and this is the number of ads we'll be purchasing. So that sum product will give you the total reach, audience reach, and this is the objective function that we have to maximize. So let's color code that with the third color. Okay. So now we have the model done. Okay. Next we run the model. Okay. Solver. All right. So the set objective is that cell that needs to be maximized. Changing cell will be that. Okay. And then the constraints are, see, any similar constraints that are contiguous can be entered as one group, one batch. Okay, so now you can't add that because this is greater than or equal to. So we do the first four, click add, and then that is greater than or equal to that. Okay, we have one more set to go, so don't click OK. Click add. But if you click OK, that's okay too, then because you can always go back with another add right there. So those two less than or equal to these two. All right. So now we have done the three major parts: objective function, changing cells, and the constraints. Now you have to make sure that this is checked for non-negativity, and the method of solving is simplex LP. Now we don't have to worry about options at this point, but if you had integer constraints, then you have to consider what kind of integer optimality tolerance percentage you want to set. If you want the optimum solution, then you need to specify 0, or you can specify 1%, 2%, 3%, so on, which means that solver will stop once it reaches that tolerance level from the best solution. So now click solve. Now this is the solution we get, and here the number of ads purchased is not an integer value. Okay, let's change this to a $sign. All right. Now that could be a problem, or you can figure out, how many you need to run. You may run two in 3 different weeks, and then one in the following week. That will average out to be 1.96875 and 6.269, which may be not very satisfying way of doing this. So if you want integer, then you can go back into solver and add an integer constraint. Add. Okay, so now this is what we want. This Changing cells is what only changing the integer constraints can be added only for changing cells. Okay, not for calculated values. So these changing cells, you can change it to int. But you have to be careful with this, because when you change it to integer, then solver will use a methodology called branch and bound, which means it will create lots and lots of LP problems and add constraints, additional constraints to restrict the variables to integer values, and select the bed. So sometimes this process can take a very long time, especially if you have lots of constraints and lots of variables. Then it can take hours and hours and hours to solve the integer problems. That is the reason why we have this option where we can set a percentage of distance between the best solution and the one that you can live with. Now, this particular problem, there are only 4 decision variables, so it's really no big deal. Solver will find the integer answer very quickly, as we will see. Okay, click OK. Now that we've added the integer constraint, click solve, and then see it finds in fraction of a second. So we have an integer answer. Now one might think that why not we just simply round the non-integer values and be done with it. But that's not going to work, because when you round, sometimes depending upon the kind of constraints we have, some constraints are greater than or equal to, in which case if you round up, you may end up with infeasibility. In the case of if you round down, you may end up with infeasibility in the case of greater than or equal to constraint. In the case of less than or equal to constraint, rounding up may end up causing infeasibility. So you really wouldn't know which way to round, and that is a problem. And also, when you round, you're very likely to miss out a different way of rounding that will give a better answer. So it is always better to insert integer constraints and solve the problem rather than just simply rounding the answers.